Power functions are functions that have terms like x to the power of n, where n is any natural number, like 1, 2, 3, etc. Power functions and limits for x approaching infinity are pretty easy to evaluate. All we have to do is determine if our power function is an even power function or if it's an odd power function. So if the exponent is even, then it's an even power function, and we can see that the general shape of the graph says that the end behavior of the function travels in the same direction. So for example, x squared, if you let x tend to positive infinity, those function outputs also tend to positive infinity. And the same is true when you let x go to negative infinity. As x travels to negative infinity, the function outputs travel to positive infinity. So for an even power function, it doesn't matter if you're traveling to positive or negative infinity, the end behavior is going in the same direction. Now, you could have a power function that has been reflected, so for example, a negative x to the nth power. In that case, these rules have to also be reflected. So make sure that if you're using the power function shortcut, that you're focusing on just the power function, not any reflections. Those would have to be taken care of after the fact. If we're looking at an odd power function, then our exponent is something like 1 or 3. And in this case, our function has odd behavior, meaning that on one side you're going up, but on the other side you're going down. So in this case, if x is traveling to positive infinity, our function outputs are also going to positive infinity. But when x is going to negative infinity, our function outputs are going to negative infinity. So this is different than the even functions where they both went in the same direction. Odd functions, their end behavior travels in opposite directions.